I figured out why the answer was 1 on number 10.
Oh, okay.
Yeah, it's actually like right in the beginning of lesson 7, like in the online textbook. It said the standard deviation of the random variable is the sigma divided by the square root of the sample size.
Oh, that's right. We didn't switch formulas.
Yeah, it's different when they give you like a number for the sample size. I completely forgot about that.
I forgot to, but yeah, that's right. That was so like question 8 in the group work where it had that different formula.
Yeah.
Yeah. Okay, that makes more sense. So.
Okay.
Oh, yep, and it says it right there on question D. I should have noticed that.
Okay.
Well, thanks for catching that before I wrote to her, and then she was like, "You guys are wrong."
Hello.
Okay, so part 2.
Hey, Callie.
Yes, ma'am.
So for lesson 7, it didn't even show up. It was showing up in my week 3 folder. So I didn't even get to it. So, I mean, was it crazy difficult, or would you think we'd be able to, like, kind of plug along with you guys?
It's a lot of formulas.
Okay.
Yeah.
So it's totally your call if you want us just to kind of go through them, or if you'd rather hold off, and then we can do it when you have time to go through it.
I can go through it with you guys now and then just go back and do it on my own, just because I'm worried that we won't get it. We won't have another time. So.
Perfect. Okay, so how about we'll start with, okay, so suppose paracomputing sold an average of U equals 45 phones per minute in 2011. Yes, that means they sold 23,652,000 phones with a standard deviation of 10, and they looked at their phone sales data and determined they are normally distributed. So 4, sample of size n equals 4 are taken from normally distributed sales data. What is the shape of the distribution? And it should be normal because it's a normal thing. Yeah. It was normally distributed before, and nothing changed that.
Yep. Number 5, sample size n equals 40 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of X? And I put normal as well.
Yep. Dual reasons. It's big, and it was normal to start with.
Yep, exactly.
Okay, I'll do 6 because it's a math one, Kate. So sample size n equals 4 is taken from the normally distributed 2011 data sales. What probability that observed that, how do you say, is it line over X, or how do we pronounce those? That symbol.
X bar.
X bar is less than 40. And so I got 0.1587.
Me too.
And Kate, for these, just FYI, it's an applet.
It is.
Yeah, that you'll plug all those into.
You guys are just plugging these in.
So you have to do the Z formula first, and then you plug the stuff into the app.
Okay, got it.
Okay, Jason, you want to do 7?
Yes. A sample of size n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed X bar is greater than 35 and less than 55? 0.9545.
That's what I got. Okay, 8's another math one. A sample size of n equals 25 is taken from the normally distributed 2011 sales data. What is the probability that X bar is greater than 41 and less than 49? And I got 0.9545.
That's what I got.
I was watching the example on the tutorial thing, and he pointed out a good thing, or that because 55 minus 45 is, the positive, and then the 49 minus 65 is the negative, the same number, that's why we get the same Z-score on those. So it kind of makes it simpler than having to do all the math.
Oh, okay.
So, because the two numbers are the same distance apart, just one's a positive, one's a negative.
Okay, that makes sense.
Okay.
I have a quick question. So when you guys are plugging into the Z-score, is the X, so I'm kind of like doing it as you guys are talking, but is the X, the bar X, is that what it's talking about?
Yeah.
So when it says that it's less than 40, would you plug in 40?
Yeah.
Oh, I see. You'd plug in. So it's
yeah, and you get that Z-score, and then so it's less than 40. It's everything. You shake everything less than that Z-score, and that's your answer.
Okay, perfect. Got it.
But
So
this
we
is
had
a
to do.
different formula, though. Do you have the new formula?
It's not the z-score formula?
It is, but it's a different z-score formula.
It's like on number 6 on question 8, how it has the standard deviation divided by the sample, square root of sample size.
Oh, got it. Okay, I just need to find. Where is it in the lesson? Oh, I see it.
6 is where it started.
I found it. It's z equals bar x minus the mean minus u over the standard deviation divided by the square root of n.
Yes.
Yeah,
Okay,
that's it.
found it. Awesome. That'll help me a lot.
And so for both 7 and 8, you have to do, you can either do the 2 formulas to get it, or if you, like I was saying, what he was pointing out was that when you put in 35 minus 45 or 55 minus 45, you're just getting opposite positive and negatives. So
Okay.
whatever way floats your boat for figuring it out.
Pretty much.
Okay. 9, a sample size of n equals 25 is taken from the normally distributed 2011 sales data. What is the probability that the observed X bar is greater than 50? So this was another z-score, the second formula. And I got 0.0062.
Yeah, that's what I got.
Okay. Let's see. And Kate, you can do 10.
Okay, samples.
No math.
Samples of size n equals 4 are taken from the right skewed 2010 phone sales data. What is the shape of the distribution of X? Or just be right skewed.
Yeah.
Yeah.
Same with, and then 11 would be normal, correct?
It's approximately normal.
Approximately normal because it's still a right skewed, isn't it?
Yeah, because it was normal because it was large enough sample to move it more, make it more normal. But on the quiz there was never an option when we were doing the last one of approximately normal. So I would assume if there was no approximately normal, we would just hit normal.
Okay. Okay.
Okay, 12. Is there a theorem that justifies your answer to question 11? Oh, well, there's that. What is the name of the theorem? So I got the central limit theorem.
Yeah.
Because the sample size in comparison to the distribution makes it normal.
Yeah, that's what I got.
Okay. Say, Kate, do you want to do 13? Because 14 and 15 will be math.
Okay, cool. Sorry, guys.
You're fine.
A sample size n equals 4 is taken from the right skewed 2010 sales data, and you want to know the probability that the observed bar x is less than 35. Can you compute this probability using the normal probability applet with the information you have, and why? I would say you can, because it's similar to all the other ones, isn't it?
I think it's a no because it's
The distribution is not.
the distribution wouldn't be normal.
Yeah. Okay. Okay. So and then the probability applet only does normal distribution, doesn't it?
Yeah.
Okay.
Yeah.
So
Yeah, because I think because with the sample being so small and it already being right skewed, that's what messes it up from being able to do it.
Okay.
Okay, 14, a sample size n equals 36 is taken from the right skewed 2010 phone sales data. What is the probability that the observed X bar is greater than 36.5? And I got 95.99.
Yeah, that's what I got.
All right, Jason, you want to do 15?
Okay. Yes. A sample size of n equals 36 is taken from the right skew 2015 people data. What is the probability that the observed X bar is between 37.5 and 42.5? I got 0.7887.
That's what I got. Awesome. Let's hit up this quiz and see what we got.
This time.
7. Okay, and we need to make sure you have your applet opened. Okay, question 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358, and round your answers 3 decimal points. So I'm guessing that just means the center.
Yeah. You guys get 0.825 or 826.
Yes. So you got Jason?
Check that again and look at exactly what it's saying.
The right of so it's the outsides.
Oh, yeah.
So
Good catch. 0.1745, is that what you got?
0.75.
175, yeah. Gotta slow down my reading. It's my favorite thing and least favorite thing about math. There's only one right answer, but there's also only one right answer.
Exactly. True that. All right, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, X, the distribution of the sample means X, or this cannot be determined from the information given. This is the reading.
That's why I'm checking to see if it. Well, it says one of 2 conditions must be satisfied in order for the distribution of sample means to be normally distributed. The parent population must be normally distributed. The sample size is large. That doesn't answer any of those. We don't have any of that information.
Smaller standard deviation.
Yeah, I'm not seeing it, which makes me think maybe it's not on there, but I'm going to pull up the reading just to make sure.
Yeah, it's not on the reading either.
You can always phone a friend for help.
Hey, Haley.
Hey, Haley.
Okay, think about the different formulas for each. Like if you just have individual observations, what's your z-score formula?
The z would be z equals
The X bar.
x minus, yeah.
And then divided by what?
Square root.
The population.
Oh. So.
Divided by just the standard deviation that they give you, right?
Right.
But if they give you a sample size, then your formula changes, right?
If the sample size was larger, then wouldn't the standard deviation be smaller?
Say that one more time.
If the sample, so if n is larger, then what effect would that have on the standard deviation? Would it be smaller?
Sounds good to me because, I mean, think about it. If you start with 9,
Because you're closer to 1.
9 would be 3, so your normal standard deviation that they gave you would just be divided by 3. And then if you have like 36, it would be divided by 6, 100 divided by 10, so on.
So it would be the distribution of the sample means then, wouldn't it?
That's what's popping out to me because
Yeah.
when you look at like a different standard deviation.
Okay.
That's what I'm thinking too.
Okay, yeah, let's do that.
Yeah, once I figured out the math issue of that, I'm like, oh, wait, divided by what? Okay, which of the following results implies that the spread in X bar decreases as the sample size increases? The normal distribution, the 68, 95, 97, 99.7, the central limit theorem, or the law of large numbers?
Well, it's not this.
I believe that's the large numbers.
That's what I'm thinking too, because it says.
And the index will be close to, yeah, that's what I've written down for the definition of.
The mean will get more and more accurate.
Yeah. So I'll do the next one. Use the following information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed with mean U equals 150.8 and a standard deviation 8.8. So question 6, Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score?
Okay, so which Z-score formula are we using? I think we're using, because it's lesson 7, I'm assuming we're doing the Z equals X minus the U over the standard deviation divided by the square root of N.
I think so, yeah.
Yeah.
Well, so her score is 160.
Except, oh yeah, do we have an N? We don't have an N though.
No, we don't.
So it must be the other formula.
Standard deviation B, 9.2. Because aren't you subtracting? With her, I remember from one of the other lessons, wouldn't you subtract 150.8 from 160 to get her standard deviation? Or no?
That's part of the process, but that's not quite it.
Not quite.
Okay.
Okay.
What I was asking for. Okay, so I think we just, so if we plug this into our normal Z thing, so then we get Z equals, our observational score is 160 minus 150.8 divided by 8.8.
Okay, yeah.
I think. Z equals 1.04.
0, or 1.045.
Yeah. Oh, and it is asking for the Z score, so yeah. So I got 1.045 as well.
Okay.
Yeah.
What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE?
Okay, so is that when we're going to go to our normal probability applet, I believe, and put in our Z?
Yeah, you put in the 1.045.
And we're wanting above, right?
Yeah, so I got 0.148.
That's what I got. Is that what you got, Jason?
Yep.
Perfect. A random sample of 5 students was selected to take the GRE. The scores are 160, 175, 163, 149, 153. What is the Z-score corresponding to the sample mean of these students' scores? So we need to get the average of these first, right?
Yeah, I'm doing that right now.
That would be an Excel issue.
So
Or I guess you could just add and divide by 5.
it's 160.
160 is the mean?
Yep.
Okay, so then
So the sample is the new score formula, right?
sorry, say it one more time.
Using the newer, like the most recent Z-score formula because we have the sample size.
Yes, I believe so.
Would be the 5.
Yeah.
Yeah. Normal mean is 150.8.
Oh, we have to have the standard deviation.
Yeah, but we're missing other pieces of information to do that one.
Yeah.
And so wouldn't it be would it be the area?
Yeah, I think you're right. Well,
Remember, the information we were given before we started question 6 is supposed to be used on the next 4 questions. So.
Oh, good point.
Oh, okay.
Okay, so 160, so it would be, the Z-score is the same then as where we were before, because the one we just found out before was with 160.
So wait a minute, we've got a sample size now.
And so now we need to, oh, you're right. So now we need to put it in the new formula. That's true. Okay, so z equals this 150.8 divided by
What would the bar x be? Would the bar x be the 160?
Yes.
Okay.
Yeah. That's what I got.
Divided by. All right.
Okay. I got 2.338.
I got 2.38. Close.
Yeah. That's what I got as well.
What'd you get, Kelly?
2.338.
Okay.
Okay, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Round your answer to 4 decimal places.
What is the problem?
Greater than 2.338.
So is that when we're going to plug this into our chart and
Yeah.
do greater than?
Yeah. .0097.
That's what I'm seeing.
So just be .01 then, right? To round
Well, it
that.
says round to 4 decimal places.
Oh, round to 4. Okay.
You got 0.0097?
Yeah.
Okay. All right. Use the information below to answer the next 5 questions. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the sampling? Oh, so number 10 is, what is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students who are selected? So approximately normal, right? Because of the sample size.
Yeah.
Mm-hmm.
Okay.
Okay. Number 11. I can do that. What is the mean of the distribution of the sample means? Sampling distribution for all possible samples of size 81 that could be drawn from the parent population.
It's 3.5, isn't it? Yeah. Is it 3.5?
That's what I'm thinking, because it does say in the information, yeah, the mean GPA is 3.5.
And it's saying the mean of the distribution of the sample. So
All of the of size 81.
that's what I'm guessing.
Yeah, I think 3.5.
Yeah, I agree.
All right.
Okay, what is the standard? Oh, sorry, Kate. Go
No,
ahead.
go ahead. You're up.
What is the standard deviation of the distribution of the sample means, sampling distribution for all possible samples of size 81 that could be drawn from the parent population? So the standard deviation is 0.7.
Yeah. Lesson 6.
Sorry, say that one more time.
Lesson 6 and 7 are really similar.
Yeah, I feel like lesson 7 is almost pulling more from 6 than from lesson 7.
Yeah, pretty much.
All right. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? So
are we going to use our graph on that one?
Let me use the second Z formula. Because you have the sample size and they're taking 81 of those.
Yeah, you're right. It is the.
It's that Z formula.
Yeah.
Okay, I got negative 150.972.
Say that again?
I don't know if I plugged stuff in wrong though.
No, but what did you say?
Oh, I said negative 150.972
For question number.
for 13.
Yeah, no, that's not going to be right.
Okay, it looks weird. We're using the second formula, aren't we?
Yes.
Yeah.
So wouldn't
That's
it would be 3.3 minus 150.8, right?
No, that's
Oh,
going to
I'm
be
totally
3
looking at the wrong. I'm
minus
totally looking at the
55.
wrong. I think I'm looking at the wrong.
So, sorry, I'm still trying to figure out the formula myself. Not helping. Let's see here. Standard deviation 0.7. I got that. N is 81. E is 3.5.
That's why I'm using the wrong set of data.
Okay, 3.5. That's what it is. 3. Yeah, me too. I was on the wrong numbers too. And I was like, why is this looking so funny?
Yeah. Would it be negative 2.597?
Say that again?
Negative 2.597.
That is also not what I got.
But then you plug it into the.
No, I didn't get that.
I don't know why I'm getting this.
You guys talk.
Callie, what are you?
Sorry, mine's showing 6.79, but I don't think that's right either. I'm trying to, for X, I think I'm in the wrong zone here.
I got 0.005.
0%. Ah, there you go. Love you too. I made this harder than I think it needed to be here. Let's see here. 0.7 divided by 9 times 3.3. Right? Plus 3. So for your X, did you get 3.756 or 6 or 7?
You're talking about for your Z-score?
The X bar should be 3.3, right?
Okay, then that's where I'm going wrong. I was using 3.3 as my Z.
Oh yeah.
Okay, so 3.3 minus 3.5. 0.2.
I got negative 2.5.
0.077. Okay, so for my Z-score, I got negative 2.574.
I got negative 2.5714.
That's what I got.
1.4?
Yeah.
I got negative 2.597, but I'm wondering if I just
I think I rounded wrong when I did it originally.
Yeah, what you're going to want to do when you're doing the division there is do your subtraction on top and then divide by the quantity of the standard deviation divided by the square root of the sample size.
Oh, okay. Yeah, that makes sense. So that way I don't get that off number from rounding wrong.
Mm-hmm.
Yeah.
Okay, so is the z-scored, is that what our probability is, or do we need to plug that in still? Let's see.
You still
Yeah,
need to
plug
put
it
that
in.
into
Yeah, that's what I was thinking. My brain's starting to get nuttier here. 2, 4, 5, 7, 1, 4. Did you get 0.9949, or am I, wait, is my shading wrong? Hang on. Where's my shading? And so it will be less than 3.3. Let me change my shading.
what number?
I got 0.0051.
What number did you plug in?
I got 0.0101.
You might still be shaded on the outsides.
Oh, yep, you're right. I had the right side on there too. Dang this chart.
No, once you get used to it, it'll be your best friend. Trust me.
Okay, so did you get 0.0051?
Yeah.
Yeah.
Yay!
And then you don't need to plug anything in. You've already got your calculations done. All you need to do is change your shading for the next one.
Nice.
Or you can just do
Oh,
one
yep, greater than.
that you got in 13. Either way, it'll work.
Is it the same answer then?
No,
No, just different.
it'll either be 1 minus the probability that you got in number 13, or you can just change the shading to everything to the right of that negative 2.57.
Oh, right.
So 0.9949.
Mm-hmm.
Yeah.
But remember to round to 3 decimal places.
Oh, so 995.
Yeah.
Are we supposed to do, yep, 3 on the other one? So it should have been 0.005, not 51. Perfect. Okay, the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. They might want to change that. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than the observed in this sample. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction.
So what's the difference? What's the difference between the mean weight and then the sample? It says there's a mean weight of passengers in commercial boats was at 185, but then the sample mean was determined to be 177.6. Which one are we using?
Well, the first one is the assumed, so that's going to be the U. And then their sample mean, the one they observed, was 177.6. So the X was 177.6.
Okay, got it.
When they did it originally. So the question is,
Okay, got it.
some will have the weight that is extreme.
Oh, so you're just doing the same.
I think we're just plugging it in.
Yeah. Put all the numbers in.
And our sample size was, N was 48, it looks like.
Okay. I got negative 1.92, but, well, negative 1.920. And then plugging it in.
Yeah, that's what I got for the z-score as well.
Sorry, say that one more time. What did you get?
Negative 1.920.
Yeah, that's what I have.
Extreme or more extreme? All right. So I got, for the probability, I got 0.972 or 0.973.
Well, but it says we have to go extreme either direction. So don't we need to highlight both the left and the right?
Said extreme or more extreme. Oh, you're right. I didn't read that part. Yeah.
So I think it's 0.0549.
Yep, you're right. Sorry, I didn't read that part in parentheses.
And we're doing 3 decimals.
Yeah, so 0.055.
Okay. I'll submit them and we'll see what we get.
Oh, okay.
Maybe if it'll let me. There it goes. Oh, we missed one. So we still got an A, but we missed question 2 was supposed, we didn't do 3 decimals. It was supposed to be 0.078.
Question
12.
12. Okay. Oh. 0.078?
Yeah, 0.078.
Okay.
Okay, so I'm going to pull this back up again.
Yeah, I'll tell him to.
Previously. What answer did you guys have previously?
0.07.
Oh, yeah, 0.
Okay.
So we missed that 3rd
Yeah.
decimal.
Yeah.
Okay, so what's question 3?
Number 3 is 0.175.
175? Okay, 4?
Number 4 is the distribution of the sample means X.
5?
The law of large numbers.
6?
1.045.
7?
0.148.
8?
2.338.
338?
Yeah. Yeah, sorry, 2.338.
Oh, sorry, 2. So
Yeah.
number 8 is 2.338.
Yes.
Okay, 9?
0.0097.
10?
Approximately normal.
11?
3.5. And then the 12 is 0.078.
And 13?
13 is 0.0051.
0.0051? Yep. Oh, it's supposed to be 3 decimals. So is it 0.005?
Oh, is it 3? Oh, it is 0.005. Yep. Sorry. Question 14 is 0.995.
15?
And question 15 is 0.055.
0.055?
Yeah. Okay, I'll submit this and make sure everything's
Perfect.
Yep, we're good.
Perfect.
All right.
Did you get it, Jason? Perfect.
Yep, got it.
Awesome, guys. Well, good. We banged out all 4 of them, so we are done.
Thanks, Haley, for joining in.
Are we Thursday? Do you want to go back to Thursdays at 9, or do you guys want to stick with a Tuesday or Wednesday?
I kind of like the Wednesday thing, just in case, like, we need to come on a Thursday.
Buys a little more time.
Yeah, so I'm fine with Wednesdays.
Are you okay with Wednesdays, Jason?
Yeah.
Perfect. We'll see you guys Wednesday at 9.
Awesome.
All
Bye.
right. Good.
Bye, you guys. Bye, Haley.
Bye.
Thank you.
Yeah,
Thank
you're
you.
welcome. If you guys, hey, before you go, if you guys want to pass on the information to Kate, is that her name?
Yeah.
Okay.
Yeah.
If you guys want me to join in on another one because you're having a particularly hard time understanding the material, just email me in advance. I will do my best to make sure that I'm not joining another hangout with another group, and
Okay.
or you guys can like individually email or call or text. I don't care.
Perfect. Sounds great. Thank you.
Thank
You're
you.
welcome.
Bye, you guys.
Bye.
Bye.